Now we'll discuss the 20th LAQ, that is second LAQ. Okay, the dihybrid cross. Okay, what is dihybrid cross first of all? It is a cross involving two true breeding plants. It is a cross between two true inbreeding plants. Okay, so here dihybrid cross is the cross which involves cross between two true breeding plants which differ in either two genes or two characters or in two genes or two characters or two pair of alleles or two pair of traits. Okay, so it is a cross between two true breeding plants which differ in either two genes or in two characters or two pair of alleles or two pair of traits is called as dihybrid cross. G.H. Mendel, that is Gregor Johann Mendel, has carried out dihybrid cross. He carried out dihybrid cross in case of the plants, the two breeding plants. The parental plants which he has chosen are one, that is, which is having, mainly taking as per the question if you go with, wherein the seed shape and seed color has taken into consideration. Seed shape and seed color. Seed shape and seed color here are taken into consideration. Here the cross between, as we are discussing, it is occurs between the two true breeding plants, that is here wherein the seed shape round and the seed color yellow. Okay, round and here it is yellow. Okay, here the two characters which are taken into consideration by G.J. Mendel, Gregor Johann, G.H. not G.H., G.J. Mendel, Gregor Johann Mendel, he has taken these two characters, that is seed shape and seed color, wherein he has taken the two homozygous, he has crossed two homozygous plants which are with the genotype capital R, capital R, capital Y, capital Y. Here the capital R, it denotes or it represents the genotype of the carrying the round shape of the seed, and capital Y denotes the genotype of the color, that is yellow color of the seed. So this is the homozygous plant, that is capital R capital, which is round and yellow plant. It is crossed with homozygous. Here homozygous, wherein all the genotypes are similar. Okay, homozygous, it is wrinkled green plant. Okay, so here small r represents the genotype of the shape of the seed, that is wrinkled, whereas small y represents the the color of the seed, that is green. So here the cross has been done. Gregor Johann Mendel has carried out these two inbreeding lines and crossed these two. The homozygous plant, that is dominant plant, which you can say that is round yellow, which is crossed with an homozygous wrinkled green color plant, seeded plant it is. This is nothing but round and yellow or wrinkled and green is nothing but of the seed, regarding the seed shape and color. Okay, so as a result of this cross, then what are the gametes which are produced from here? Gametes which are produced over here, capital R, here it is a dihybrid cross, so capital R, capital Y, small r, small y are the gametes which are produced over here. Which these gametes, here must remember that gametes always must be encircled, which resulted in the formation of capital R, capital Y, small y. This is the F1 generation. The F1 generation, which is an round yellow seeded plant. Round and yellow seeded plant. Okay. So as we have seen that Gregor Johann Mendel, who has crossed these two plants, wherein he has taken these two characters, that is seed color and seed shape, wherein yellow, round, which are considered to be the dominant, the homozygous plant, wrinkled, green, homozygous recessive plant, these two plants are crossed and the gametes are as such, which resulted in the formation of capital R, capital Y, small y, which is an heterozygous round yellow seeded plant produced. So, and this F1 generation, now what is done to this F1 generation? The F1 generation plants are selved over here. Okay, the F1 generation plants which are obtained over here, that is capital R, capital Y, small y. These are the F1 offsprings which are selved. These are selved over here. These are selfing. Selfing of F1 offsprings is done, which can be, one can consider as a male parent and one can as an female parent, which resulted in the formation of the gametes which are produced, capital R, capital Y, capital R, small y, then small r, capital Y, small r, small y. So these four are the gametes which are produced from that of by the selfing of F1 generation. Okay, the offsprings which have been obtained as a result of F1 generation is the first filial generation. Here which obtained is, here is capital R, capital Y, small y, which is an heterozygous dominant parent, or dominant here. Why dominant I am calling is that here it is carrying out the dominant character, that is round and yellow. Heterozygous offspring is formed, that is which carries the character that is round and yellow seeded plant, which is selved, which results in the formation of the gametes, that is capital R, capital Y, capital R, small y, small r, capital Y, small r, small y. These are the gametes. Again, remember the rule, that is the gametes must always be encircled. Now coming to that of designing of the punnet square. Designing of the punnet square. So if we go over that of the male and the female offsprings, for the sake of this one, I am rubbing over the gametes over here. Capital R, capital Y, one gamete, capital R, small y, other gamete, small r, capital Y, small r, small y. The same gametes over here also. Okay, now coming to that drawing of the punnet square, now we will go with that of Okay. Capital R, capital Y, then capital R, small y, small r, capital Y, then small r, small y. This of, can say, male gametes, then this of female gametes denotes that capital R, capital Y, capital R, small y, small r, capital Y, small r, small y. Okay, drawing the Punnett square now. Now, if the fusion of the gametes takes place here, then what does it result in? Capital R, capital R, capital Y, capital Y. The first two gametes. Then capital R, capital R, capital Y, small y. Next one, capital R, small r, capital Y, capital Y. Then again, capital R, small r, capital Y, small y. Now coming to that of the next set of fusion with that of next set. Capital R, capital R, capital Y, small y. Capital R, small y, small y. Capital R, small r, capital Y, small y. Capital R, small y, small y. Then coming to that of the next row of the gamete fusion, that is capital R, small r, capital Y, capital Y. Capital R, small r, capital Y, small y. Small r, capital Y's. Small r, capital Y, small y. Now coming to that of the last row fusion of the gametes. Capital R, small r, capital Y, small y. Capital R, small y, small y. Small r, capital Y, small y. Small r, small y, small y. Okay. So this is the Punnett square. Bateson and Punnett have proposed this, have given out this checkerboard or Punnett square in order to know the fusion of the gametes which resulted in the different offsprings, formation of the different offsprings. Okay. So here what is this? Or first we will discuss about, we have to know about both the genotypic as well as the phenotypic ratio. First we will discuss about the phenotypic ratio. Coming to that of the phenotypic ratio. Phenotype is the physical appearance or the output which is going to give. Genotype is the genetic expression. Okay, coming to that of the phenotype over here, phenotypic ratio. Here it is capital R, as we have discussed that always it represents the dominant character, that is round shape. Capital Y denotes the dominant character, that is yellow color of the seed. Okay, so now it is what it is now. Phenotype is round yellow. So this is round yellow, and whereas coming over here it is also round yellow. Then coming over here it is also round yellow, and coming to the next row, here also it is round and yellow, but here it is round and green. Why? Because here the next set of genes which is denoted by small y, wherein the color or the genotype which it represents is that the green color of the seed is denoted by the genotype small y. Now again here is round yellow. Here again it is round green. Okay, here it is again round yellow. Here also round yellow. Here small r, the genotype small r. it represents the other shape of the seed. The other shape of the seed is here wrinkled. Okay, wrinkled yellow. Okay, here also it is wrinkled yellow. Okay, and here it is round yellow, and here it is round, but it is genotype is here small y, which is green, and here it is wrinkled yellow, and here it is pure wrinkled green color seeded. Okay, so here we have as a result of the fusion, or rather as a result of the crossing of the F1 offsprings, we are going to get F2 offsprings. The total number of F2 offsprings which we are going to get are total number are 16. Total number are 16. Out of that, we are going to look further phenotypic as well as genotypic ratio. Here the coming to that of phenotypic ratio, that is a phenotypic, that is a physical appearance. Here we said how many round yellow are there. Phenotypic ratio, how many round, coming to that of round yellow. Okay, next round green, next wrinkled yellow, next is wrinkled yellow, and the last one is wrinkled green. Wrinkled green. Okay, how many round yellow are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So total 9 are there. 9 round yellow offsprings are there, which are formed as a result of second filial, or which are the second filial, which belong to the second filial generation, which are formed as a result of the union of the or the selfing of the F1 generation. That is, now coming to that of the next phenotype, that is round green. 1 round green, 2 and 3. So 3 round and green offsprings. Now coming to that of the next phenotype, that is wrinkled green. Wrinkled yellow. 1, 2 and 3 are wrinkled yellow are there. Now coming to that of the balance, that is 1, that is wrinkled green. Okay, so here the phenotypic ratio can be noted as in this way, that is 9:3:3:1 is the phenotypic ratio of second filial generation, which is formed as a result of selfing the F1 generation. The total number of plants or the offsprings which are produced at the end of this F2 generation, that is the second filial generation, is 16. Out of that, when we are going to discuss about the phenotypic ratio, 9 shows 9 plants, 9 offsprings are round yellow, and whereas 3 are round green and 3 are wrinkled yellow, and there is only one plant that is wrinkled green. So that's what the phenotypic ratio. So if we take in the manner of the ratio, we can say that is, it is usually 3:1. What is this 3:1? For example, we are telling that in what is 3:1 ratio, if you denote over here. Here the 3:1 ratio is going to denote regarding the color of the seed. Not only the color of the seed, but also the shape of the seed. Not only the color of the seed, but also the shape of the seed. 3:1 ratio. For example, if you take how many yellow color plants are there. Yellow color seeded plants are there. 1, 2. See. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. Only 9 yellow colors. 9. 9 plus again 10, 11, 12. That means here total 9 plus 3 are yellow colored plants. 9 plus 3 are total yellow color plants over here. Okay. Whereas the rest of the plants, 9 plus 3 means 9, 10, 11, 12. Then about other 4 plants out of the 16 offsprings, if we go with. Out of that you can say green colored plant. 1, 2, 3 and 4. 1, 2, 3 and 4. Here out of that we can say that 9 are. Why did I write over here 9 plus 3? Wherein out of these 9 are round and yellow, okay, whereas 3 are wrinkled yellow. That's why I have separated that. Okay, so 9 are round yellow, whereas 3 are wrinkled yellow. Okay, now coming to the next one, that is green. How many are green? Here also you can say 3 plus 1. That is 3 are here round green plants, whereas 1 is the, what you can say, 1, the rest 1 is the pure wrinkled green color plant over here. So that's what over here we can go with. So we can summarize as I have already discussed. Okay, as we have discussed the F2 generation, which is showing the 16 offsprings. Out of 16 offsprings, what is the phenotypic as well as the genotypic ratio? Here the phenotypic ratio which is discussed over here is 9:3:3:1, wherein 9 plants are of round yellow plants and 3 plants are round green plants and 3 are wrinkled yellow and 1 is wrinkled green plant, that is. And the one what I have been discussing regarding the color, that 9 plus 3, that is 9 are pure round yellow color plants, whereas these 3 are the what you can say wrinkled yellow color plants. And whereas coming to that of the rest of the plants, that is 3 plus 1, in this 3 are round green color plants and only one is wrinkled green color plants. Total it exists in the form of 3:1 ratio. 3:1 ratio. And not only the color of the seed, but also the shape of the seed also exists in this same ratio. We can say, that is 3/4 and 1/4 respectively. 3/4 and 1/4. 3/4 and 1/4 respectively. 3/4, 1/4 in the sense, if at all 4 plants are produced, out of the 3 are going to be the yellow colored and 1 is going to be the green colored, you can go with. So that's what about the ratio over here. And we have discussed over here the phenotypic ratio. Now coming to that of the genotypic ratio. Regarding the genotypic ratio, it has to be very much particular over here, wherein, so the genotypic ratio, it shows it is capital R, capital R, capital Y, capital Y. It's nothing but an homozygous plant wherein all are the dominant genotype. This offspring contains the dominant genotype complete. Capital R is the genotype which represents the round shape, capital Y which represents the yellow color of the seed. So how many are there? Capital R's and capital Y's, only 1. So the genotype we can go with is the genotypic ratio capital R, capital R, capital Y is only 1. This is the genotypic ratio. This is the genotypic ratio, capital R, capital R, capital Y, capital Y. This is the homozygous dominant round yellow seeded plant, only one. Okay. Now coming to that of the next set, that is capital R, capital R, capital Y, small y genotype. So capital R, capital R, capital Y, small y. How many are there? 2 are there. These are there are 2 genotypes. This is the heterozygous round yellow plants, that is capital R carrying the genotype capital R, capital R, capital Y, small y. Thus, then coming to the next one, that is capital R, small r, capital Y, capital Y. Okay. So, are there any similar genotypes like this, which is also a heterozygous genotype, which is carrying the phenotypic character, that is round yellow, capital R, small r, capital Y, capital Y. Capital R, small r, capital Y, capital Y. How many are there? 2 are there. Okay. Now coming to that of the next genotype, that is capital R, small r, capital Y, small y. How many are there? 1, 2, 3 and 4. Okay. So total 4 are there. So the plants having the genotype capital R, small r, capital Y, small y are total 4 are there, which is having the phenotypic character, that is round yellow. Okay. Now coming to that of the next genotype, we haven't discussed this genotype. Okay. Now capital R, small y, small y. How many are there? Capital R, small y, small y. 1. Only 1 is there. Capital R, small y, small y. How many are there? 1 genotype is there. This capital R, small y is an heterozygous. Okay. It is a heterozygous genotype. Okay. Heterozygous genotype, here it is. So it is only 1 is there. Now coming to that of another genotype, that is capital R, small y, small y. How many are there? 1, then 2. 2 are there. Capital R, small y, small y. How many genotypes are there? 1 and 2. Now coming to that of the another genotypes. What are the other genotypes? That is small r, capital Y, capital Y. How many are there? Small r, capital Y, capital. Only 1 is there. 1 genotype. Then small r, capital Y, small y. How many are there? 2. Then small r, small y, small y. How many are there? 1. So here, see, if we total all the genotypes, if we just sum up all the genotypes, we will get the total number of the offsprings which are produced at the end of F2 generation. That is, of total number of offsprings is 16. See here, 2 plus 1, 3, 5, 9, 10, 12, 13, 14, 15, 16. This is what about the genotypic ratio we can go with. So as we have discussed that, the phenotypic ratio is 9:3:3:1. If we go with the genotypic ratio, how will it be? It is 1:2. You can go with that of in a sequence. If you have to go with that of, I can write over here. That is, the genotypic ratio is like this: 1:2, 2:2, 2:4:1:2, 1:2:1:1. Okay. Okay. So this is the genotypic ratio. Okay. So here the genotypic ratio, which is showing capital R, capital Y, capital I, only 1 genotype. These are the 2 genotypes. So all these. Okay. So this is the end of the genotypic ratio. Okay. So that's what. Now, what is the reason? And at the end of carrying out this dihybrid cross, Mendel has proposed, basing upon this carrying out of or crossing the two true breeding plants, as a result of this, Mendel has proposed independent assortment. This independent assortment, the law of independent assortment, which was proposed by Gregor Johann Mendel, states that the traits what are been there here, isn't it? Here there are two pairs or set of traits have been crossed over here. This set of traits which have been combined in a hybrid, what happened is that as a result of this, here what happened is that nothing is that here a combination of the characters, that is two traits of or two pairs of traits are independent to that of other pair of traits. Two pair of traits are independent with that of other pair of traits. So that's what. So finally, if we come to the conclusion, through this dihybrid cross, Mendel has proposed law of independent assortment, which states that the pair of traits which are combined in a hybrid, that is the assortment, or you can say the segregation of a pair of traits is independent to that of other pair of traits. The segregation of a pair of traits is independent to that of other pair of traits. So here comes the end of the dihybrid cross, that is the question number 20.